In this video we would like to introduce our vibration switches VS10, 11, and 12. The task of vibration switches is to trigger a switch signal when the vibration amplitude exceeds the adjusted limit. Vibration switches are used, for example, as alarm device in the case of machine failure or for emergency shutdown. The instruments shown here have properties far beyond such conventional vibration switches. Vibrations occur when masses rotate or move back and forth. Vibration can be an indicator of unbalanced rotors, bearing clearance or misalignment of shafts. Immediate action is recommended to avoid further damage or even danger to persons or building infrastructure. Vibration is an early indicator for wear. For example, bearing problems can be detected at an early stage by measuring vibration acceleration without dismantling the machine. Changes in the vibration spectrum can be recognized long before they become susceptible or audible for humans. Permanent vibration monitoring helps to detect emerging problems. When the vibration magnitude is slowly rising, a maintenance can be scheduled before it comes to breakdown. This may help to save maintenance cost and to avoid production loss. Applications are, however, not only in predictive maintenance. The VS10-12 are also versatile instruments in quality control. Due to their frequency and amplitude ranges, these vibration switches are well suited for monitoring large structures, like buildings or towers, but also for shock vibration. What makes the difference between our vibration switches and conventional devices? The VS10-12 can monitor in time domain. That means they measure RMS, or peak values of acceleration and velocity. A special feature is the frequency domain mode, which means that the vibration switch continuously performs a frequency analysis. The vibration signal, often a mix of frequencies, is divided into its frequency components. This allows a much deeper insight into vibration phenomena than the common wideband monitoring. Frequency analysis is a useful tool to find the source of a vibration problem. Technically speaking, the VS10-12 are compact and very economic vibration analyzers. Besides the signal conditioning electronics, they include a high-quality piezoelectric. Unlike common low-cost devices, using MEMS accelerometers, these vibration switches cover a wide measuring range from 0.1 to 1000 meters per second squared. This allows the measurement of very low seismic vibration as well as shock impulses. Signaling of alarms is done via the relay switch output. The connection of the relay contacts and the power supply is done via terminal blocks which become accessible after opening the lid. For operation, a supply voltage between 5 and 30 volts DC is needed. Inside the case is also a USB socket for setting up the device. A 4-wire connection cable is inserted through a waterproof cable gland. The vibration switches have a protection grade of IP67. The vibration switch is mounted by means of an integral M8 stud bolt. Its main axis of sensitivity is in the direction of the stud bolt. In transverse direction the sensitivity is nearly zero. Best suited for vibration measurement at machines are points close to the source of vibration. For rotating shafts, for example of electric motors, the vibration switch can be mounted in radial direction at the bearing case. Especially for vibration measurement in the kilohertz range, it is recommended to choose only stiff components for mounting and to avoid joints between components, because they may attenuate high vibration frequencies. Massive cast iron parts are usually good points for attachment, whereas light components made of sheet metal or plastics are generally not suited. An optical information about the current alarm condition is provided by green and red LEDs with 360-degree visibility. The setup process is done by means of a USB interface and the supplied PC software tool. This software also allows measurement and recording with the vibration switches. There is a multitude of setup options to adapt the vibration switch to your application. The devices are detected automatically as virtual COM ports without installing driver software. The last settings will be shown in the setup window after clicking search. Let's start with the settings for time domain monitoring. The settings are ordered as function blocks: gain, filters, alarm comparator, relay output. The vibration switches have 3 gains. In most cases you will choose automatic gain to find the optimum gain, depending on the measured magnitude. In applications with very unsteady amplitudes, it may be better to measure with a fixed gain to avoid permanent gain changing. You may select from a number of band filters. An integrator can be used to calculate vibration velocity. The standard setting for condition monitoring at rotating machinery to ISO 2816 is velocity from 10 to 1000 Hz. The vibration switches are also suited for monitoring slow-running machines and reciprocating machines at lower frequencies. Low frequencies can be suppressed using a high-pass filter. This may be useful, for example, to measure vibration from roller bearings. The total frequency range extends from 0.1 Hz to 10 kHz. In time domain, you may choose between RMS and peak monitoring. RMS is the square mean value over the last second. The peak value shows the highest absolute vibration amplitude of the past second. The alarm limit is the RMS or peak trip value of the relay. The warning limit is entered in % of the alarm limit. It can be used to give an optical pre-alarm with the LEDs. The relay output can be configured as neutrally closed or neutrally open. To suppress short vibration transients, a delay time can be set. The alarm event has to persist during the entire period in order to trip an alarm. This can be useful at run-up or in the presence of occasional vibration pulses which are not of interest. A power-on delay and a minimum hold time can also be adjusted. Click on the RMS Peak tab to open the RMS Peak measurement window. It shows an amplitude time diagram, which can be exported as text table or as graphics. When these settings are completed, the vibration switch can be unplugged from USB. Now it monitors vibration as a standalone device. All settings are stored in a non-volatile memory. The relay output and the LEDs indicate vibration alarms. The VS10-12 can be connected, for example, to a PLC input or to alarm devices. We will show you now how the vibration switches can be used for frequency selective monitoring in frequency domain. Click the tab FFT. You will see a spectral diagram with a resolution of 360 lines. The amplitude is scaled and peak value of acceleration. 2 frequency ranges are available: 0.2 to 1000 Hz and 20 Hz to 10 kHz. Let's use a vibration frequency of 320 Hz in this example. A cursor can be used to measure amplitudes and frequencies. A distinguishing feature is the user-defined limit curve that can be entered by means of 10 frequencies and 10 amplitudes. We assume a frequency band from 300 to 340 Hz to envelop the 320 Hz line. The amplitude limit we set at 10 meters per second squared. When a frequency line crosses the limit curve, the relay will switch over. The switch behavior is the same as shown for time domain monitoring. This enables frequency selective vibration monitoring. Typical applications are in quality control or acceptance tests, for example, when machines with gearboxes are tested, which generate a mix of several vibration frequencies. As shown for time domain monitoring, you can now unplug the USB cable and use the vibration switch's standalone monitor in FFT mode. A basic setup is also possible without PC, by means of the teach-in function. Inside the case is a push button, which can be pressed through a hole in the lid after removing a cover screw. After pressing the button, the device will measure vibration for some seconds and then calculate the limit value by multiplying the measured amplitude with a user selectable factor. The teach-in function also operates in FFT mode. The vibration switch is offered in 3 versions. Model VS10 monitors RMS and peak values in time domain only. Model VS11 works in time and frequency domain. Model VS12 also monitors in time and frequency domain. This model has an 8-pin connector, making the USB interface accessible from outside the case. With the measurement functions of the PC software, the VS12 can be operated like a USB sensor. The relay output is also provided at the socket. The VS12 is powered from the PC via USB.